one big one, the HSC. And we get colony units. Then we get our cells. So, the cells, everything comes from bone marrow. Because after the embryonic development, that's where it migrated to, into the bone marrow. Now, what about my plasma? Because plasma is not these formed elements. These are my formed elements. Blood cells, platelets. So my plasma, how do I get any type of material into my plasma? I have to consume that.
The CLP and the CMP, those are platelets that then form the formed elements.
Those are my colonies. So my hematopoietic, my HSC, okay, has to form these two colonies. The colony of lymphocytic cells. Can't remember what the P stands for. Right off the top of my head. Not platelets. Okay. Because platelets come in down here from a megakaryocyte.
Oh, okay.
Which we'll talk about. Okay, and then the CM is the colony of the monocytic.
Yeah,
okay.
I wrote that part down. Okay.
I'll look that back up. I don't know if it's if it's referring to it being diplury. Okay, I'll look that back up. So that from that colony for the lymphs and the colony for the monos are what you get remaining cells from.
Gotcha.
My plasma, I'm dependent on my foodstuffs. So that is how we're going to get our components of the blood. So now, the erythrocytes. What we know, red blood cells, okay? Their job. Their job, deliver oxygen. Yes, they can pick up CO2, but their focus, carry oxygen. They don't carry as much CO2 as they do oxygen. Now, let's take a peek, because when I asked what process it was that in the cell that uses oxygen, okay, let's just do a quick review on that. So, what I'm going to do, that's going to be my tissue, okay? My tissue is made up of cells. Everybody with me? Okay? I have a blood supply to this tissue level. The only place that the exchange of anything can occur is at the level of the capillaries. Okay? So, I'm going to have my arterial and my venous end. Arterial blood has left the heart, should be oxygenated, should be able to enter into the tissues. Is everybody following me? So, I'll end up having the smallest artery that can exist, the arterioles and the metarterioles, okay? And then I'll have my venous end, which we refer to as being deoxygenated blood, okay? And this is the side that returns to the heart. So I'll have my venous end, once again, the smallest part, venules, okay, going into small and medium and larger veins. In the middle is my capillary bed. All right? And arterial blood flows in. One of the things that's hopefully being transported in this arterial blood is oxygen. Now, remember, if this is a tissue with the cells, in between we have extracellular fluid. Does everybody remember that? Mm-hmm. Okay? So I've got extracellular fluid. And if this tissue has been active, it would be demanding oxygen. Is everybody following me? Mm-hmm. So oxygen would get to move out at this arterial end. And the cells that are working at this tissue level would have been needing to make energy. Because if they are working, they need energy. Yes, no, maybe. Mm-hmm. All right, so located in the cell is a mitochondria. Everybody with me? Some of you look like you're going to sleep. All right. Now, energy. If they've been busy, let's say that they've been using glucose, an energy source. All right? So we'll have our glucoses. Glucoses, if you remember, make their way into the cell. They go through glycolysis, and the two pyruvates make their way to the mitochondria, and through the Krebs cycle and the electron transport chain make the ATPs. Where in this process is the oxygen used?
In the beginning.
You don't remember?
Mm-mm.
Do you remember how, once we get all of those little electrons to the electron transport chain, and they begin to bump down the electron transport chain and form ATPs. When they have bumped down the chain and that electron is no longer used, the final electron acceptor is oxygen. Anybody else's head going? Why am I reviewing this?
Once I produce the CO2.
As we go through that process, CO2 gets produced. CO2 is a waste, but that is the only use of oxygen in the body. I'll say it again. That is the only use of oxygen in the body. If that doesn't blow your mind, I don't know what will, okay? It takes it to this point, to that organelle, to that process for the oxygen to be needed.
So, like, if someone's, like, not getting blood flow to their hand, right? So, because that process isn't happening, that's why you maybe have to amputate it.
Yes.
Because it's not exchanging.
Because that oxygen is not available. We do not store ATP. We have to, now we can produce a little bit of ATP just in glycolysis, but it's not a lot. If you remember, the final production of ATP in cellular respiration was roughly 36 to 38 ATPs, okay? Glycolysis gives us 2. So that's a huge difference, okay? So if they're not getting ATP production, the cell cannot be active, the tissue can't be active, both will die. This is why restoring blood flow to tissues is so important, because just a minor cutoff of blood flow to tissues can lead to those tissues dying. But in the process of how important oxygen is, I mean, we tend to have that particular gas touted to us, right? Oxygen, 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 okay? Can't get more important than that. Or give you the importance of how important a mitochondrion is to the body. Think about your heart. Your heart is cardiac muscle. Does it stop? It stops. You stop. Just saying. Okay? Can you even begin to imagine how many mitochondria are needed in one cell of the heart? Or how important that is to that mitochondrion of that one cell of the heart. I can't stress the importance enough. So now, once we have gone through that process, CO2 becomes a waste, along with a bunch of other things, okay? The goal now is to make sure that I have enough pressure. And how am I going to create that pressure in this extracellular fluid of this tissue? My osmotic pressure, my osmolarity. So it would be based on pressures between this extracellular fluid and particles in the blood. So my goal would be that pressures are good so that something such as the CO2 can go to the venous end, make its way